Hi, everybody. Welcome to the Fall Jam. We're going to do a quick workshop going over some basic setup stuff that everyone will want to know before we get started for the theme jam reveal. And yeah, so we're going to start off with GitHub. So who here knows what GitHub is? How many of you have used it before? I saw some hands go down. Okay, so, oh God, that went faster. So GitHub is basically a software. It's source control, so you push everything to a online file folder. It's called a repository or a repo, and then everyone can copy that onto their local computer and push it onto the remote one back and forth, and it'll automatically, say what did this person do different, what did this person do different, and merge it all together. There's a little bit of technicality that I'll get into with it, but it's very helpful with group projects. So what is GitHub? This will explain it better than what I can. Let's watch this short video.
Okay. What is GitHub? Well, GitHub is a platform that helps people solve problems by building software together. So how does it work? This is Sam. Sam works on tractors all day, but not in the way you might be thinking. She builds the software that helps make tractors more efficient. And she does this on GitHub with the help of her team, BJ, Melinda, and Mike. Now, even though they all work on the same project, Sam and her team don't all work in the same part of the world. This is Eddie. Eddie also works on tractors all day, except he actually works on the tractors all day. And this is the Harvester L700. It's the latest flagship in the company's fleet of tractors. It's full of sensors and processors that produce a ton of diagnostic data. Eddie has a great idea for how farmers might share their data and improve their harvests. So Eddie opens an issue on GitHub. Issues are discussion threads where people can report bugs, request features, or even just ask questions. Sam is the first one on her team to see Eddie's issue, and she thinks that VJ would be the best person to start the job. And here's where we get into the nuts and bolts. Eddie isn't the only person using the Harvester L700. All over the world, other tractors are collecting moisture data, and they need to keep running smoothly even while VJ is working on the new features. He needs a dedicated place to experiment, so none of his changes end up on the farm before they're ready. So he creates a branch of the code, an alternate timeline where he can safely make changes to the software. Now he's ready to start writing a new feature. GitHub tracks VJ's changes and saves snapshots of his progress. When he's ready to collaborate on the changes with his team, he opens a pull request on GitHub. Pull requests let you show others the changes you're proposing so they can review and discuss them. This means VJ's teammates can help with roadblocks and even make improvements. On GitHub, everyone has a copy of the project. So if Melinda has an idea for something that will help make VJ's work even better, she can add it to the branch herself. GitHub keeps a record of everyone's contributions and feedback from the pull request, alongside relevant messages from the team's other systems. Once the team has signed off on the changes, VJ can incorporate the new code into the project. The new feature will be available to everyone as soon as he merges it in. Now farmers everywhere can all benefit from Eddie's great idea. But this is really only the beginning of the story. Because GitHub is the largest community of developers in the world, with millions of people sharing their projects, Eddie's idea could end up helping people in unimaginable ways. What kinds of problems are you trying to solve? Whether you're an engineer, a code enthusiast, or even a farmer trying to harvest grain, software touches every corner of our lives. GitHub is where people build that software. It's how they build software. Together.
Okay. This is a very basic overview of everything. We'll get into more detail as we go on. But to get started, if you don't have a GitHub account already, to get one made, you're going to want to go to github.com. You're going to follow the sign up prompts, and then you want to use your personal email. Do not use your student email. That's tied to your GitHub Enterprise account if you're a software developer or just any kind of student. Make sure you use your personal email. Just use your personal. Causes a lot of problems if you don't.
Okay.
No.
What?
Come on. There we go. All right, so this is the repository. So when you open up a GitHub repository, it'll look like this. You'll see a big file structure here with a little button up here for the code. And then you'll also have a README that's usually included, and you can see the README file right here, but then the actual contents of which will be displayed down here for you to read. That's kind of like just a description. You really don't need to worry about that unless it's a professional project. So the repo is just going to be an entire project. It's going to include all the files for your project, all the code that you have. To make a repo, you're going to want to make one on your local machine. So you'll make what's called a local repo. So you have a folder on your machine. You'll tell Git, this is a repo now. This folder is my repo, and it's a local repo. And then you'll push it to the online version, and GitHub will create a remote version of your repo that other people can then clone onto their machine to make their own version of the local repo. To do that, you're going to want to go up to this little green code button, and then you'll drop down, and then it'll have a button that says either download or copy the link, and then you can use whatever software you want to use that link to clone the repo. So once you've cloned the repo, the way you interact with the files on it are going to be through what are called pushes and pulls. So when you push something, that's when you're pushing code from your local machine into the remote machine. And when you're pulling something down from the remote machine onto your local machine. So let's say person A has made some changes on the project. They're going to push those changes to the project. Person B wants to make changes too, but they need whatever person A did. So they're going to pull those changes onto their local project, merge them in. It should automatically do this. And then once they've pulled those changes, they make their changes, they can then push back up to the remote repo. So a thing to remember is to just make sure that you're pushing and pulling from the correct branch. We'll get into what those are in a second. And always pull before pushing. It never hurts to do it. If you don't need to pull before you push, it'll just do nothing. So it always helps to make sure you pull before you push. Yes?
Question was setting up the account. It says how many teammates we be working with.
It doesn't really matter. Just put like 4 or 5. Yeah, it's just for small time thing. Thank you. All right, so branches. So this here is Git Kraken. It's one of the 3 software that we recommend. It does a really good job of visualizing branches. So you can see here that we have our main branch here, and then we have where people have kind of branched off of the main branch, and then they're merging. The main branch is going out into their own branch, and then they're doing changes and then merging it back in. All right, so the main and master branch should be the most stable working version of your project. You usually won't really touch it, especially during a game jam, until the very end or the very start. And once you've made your main branch, that's your base line, then you're going to want to make a development branch where things can, that's like your working branch of everything that you have. So you have a development branch, then you'll branch off of that for individuals, and then everyone will merge their changes back into development. And then when development is stable and everything's working and everyone's code's all good at a stopping point for something, then you move it back over to main, and main's like your working version. So dev is like your kind of like precursor test version where you want to make sure that everything's safe. You don't want to push anything out to main before it's ready to go. So to make a new branch, while you're on a current branch, there will be multiple ways to do this, but you'll find the option to create a new branch here. And that'll create a new branch off of your current branch, like a tree. So if I'm on main, it'll create a branch off of main. If I'm on dev, it'll create a branch off of dev. And when I merge those branches back up, I'll have to merge to the parent branch. So I'll have to merge, if I merged off of dev or branched off of dev, I'll have to merge back into dev. All right. So then you have local versus remote branches. So sometimes you'll make a branch, but you won't push it onto, you got to make sure you push it onto the remote server. So you can make a branch on your local machine, but if you don't push it, then it won't show up on other people's machines. So they won't know that you have a branch. So if you're going to make a branch, make sure you push it so that other people know where it is and what you're doing. And that way they can also see your code, merge it into their own code if they need it. Sometimes you might want to make a local branch and not push it in case you're doing something to just bug test or something like that. So you'll make a branch do whatever change you want, merge it back into your own local branch, and then push it back up once that's done. It never sees the light of day on the internet, but it really depends on the situation. The biggest trouble comes with the merging of branches. So once you're done doing any changes, this step right here where you're merging this branch back into this branch, you'll usually just push it up and say, hey, I have branch A here and I want to merge it into branch B, and GitHub will automatically do this. Now the problem comes when you run into merge conflicts. So here's a hypothetical example. Grace and Joey are working in different branches. Both edit the same file as part of their changes. Grace finishes first and merges her changes to the development branch. Next, Joey goes to merge his changes. Uh-oh, there's a big problem. Joey's changes were based off of dev before Grace's changes got merged in. He didn't pull before he pushed. So now there's a conflict. Whose changes get to stay? So to fix this, you have to manually go in and pick which changes are the ones that you want to keep, and then delete the other ones, and give Git a definitive answer on what the final code should look like. So here are the 3 GitHub applications that we recommend. First up is Git Kraken. It's not perfect, but it does a really good job of visualizing the whole branch system, if that seems a little confusing to you. Then we have GitHub Desktop, which is by GitHub themselves. It's the most robust. It's definitely the easiest to use and safest to use for most projects, unless you're using Unreal, which I've ran into some problems with it. I would recommend Git Kraken if you're going to do Unreal. And then you have Git Bash, which if you want to feel like elite hacker code man, or do it all by hand. It allows for direct messages and access commands, so you can do some really crazy stuff if you really want to, but it may be harder to find errors, that sort of thing. So that's GitHub. Do we have any questions on GitHub before we go? Yes, so we actually have links here, and I'll go ahead. Actually, officers, do you know where this is in the... It should be in that folder with all our presentations. If you guys can just go ahead and post it on the announcements channel. So it'll be posted in just a second in the announcements channel, and you can scroll through the thing and get the links right there.
Do you recommend we go ahead and download like GitHub Desktop?
Yes.
Okay.
If you're going to be doing the jam tonight, I recommend you get GitHub as soon as you can. Any other questions? Everyone understand it well enough? Cool.
Oh, one thing I was going to say is Git Kraken has a file size limit for pushing of about I think 500 megabytes or something. I don't know. In that case, it'll say a problem when you try to push on Git Kraken, but you can just open one of the other things, either GitHub Desktop or Git Bash, and push from there.
Yeah, I will recommend Git Bash is tiny and really easy to install. So whichever other one you get, it's always a good idea to have Git Bash as a backup in case one of them starts breaking. So yeah, all the links will be up soon. Jack, just shout out whenever that's done. Thank you. Oh yeah, do you have something?
I have the link.
Okay. All right. Any more questions? Yes. Mm-hmm. I'm not sure if Visual Studio has that built in. I know Unreal Engine has a built-in support for it, but just to make things easier and not have to worry about what engine you're using, you can just use one of these 3, and we all know these very well because a lot of the computer science students have gone through hell and back with these software, and in our previous club projects as well. So these are tried and tested. We know how to work with them, and if you run into a problem, there's a good chance we can help you solve it. Yes. Is it? Okay, cool. Well, if anyone knows how to set that up, please feel free to share. All right, move on. All right, so next up is scope and pre-production. So this is just a little bit on how to make sure you don't make a game jam idea that's way too big to make in the time that you have. So some general terms to start with. Pre-production is going to be laying out the roadmap for your game and how you're going to make it. This is mostly what you'll be doing tonight and in the next few days. Scope is basically the expected size of your project, right? If you're going to make a statue, how big do you expect the statue to be? Is it going to be a Statue of Liberty type statue? Is it going to be a little statue that sits on your mantelpiece? Or is it going to be sort of a medium-sized statue that's going to be in Central Park, So we're probably looking for something more close to the mantle size project, have something very small, want to keep your scope as small as you can. Think about a minimum viable product. What's the least you can put into your game that will get you the result that you want. That's a playable, full experience. And then scope creep is what you want to avoid. So this was what happens when they're like, oh, let's add this feature. This will be super cool. We need another week, and things start to kind of spiral out of control. So just make sure you have a nice, robust idea of what is important to your idea, what are the essential things that you need, and that way you'll avoid scope creep and make sure your scope is nice and tight. So because we're making small projects in a short period of time, focus on a polished vertical slice. So basically, you might have a game idea that could take a lot of fleshing out, right? Maybe you have this crazy dungeon crawler with all these cool mechanics. Don't try to make a very introductory part of the game. Don't do like the first tutorial levels, and don't do the crazy last part of the game either. Try to take a vertical slice somewhere in the middle of whatever kind of game you're trying to make that showcases all the core mechanics and the complete experience of the gameplay loop. Define what the central mechanic of your game is. There should be one central mechanic, especially for a jam like this. Define some pillars. These are basically going to be the building blocks of your game. For example, God of War has cinematic feeling, visceral combat, and good storytelling. Those are its pillars. So it tries to adhere to those in everything that it does. So make your own pillars and make sure that your game adheres to those at all points. So a couple roles in what they want to do relating to this. So if you're kind of planning on being a game designer, make sure you try to list out the game mechanics, what the core gameplay will be, and any settings you might want to have in the game. Artists, try to think of assets that that need to be created in order for the game to be made, and what priority and time frame those assets are going to need. Programmer, try to list gameplay features that you think you can create, how you're going to do them, talk it over with your team on same thing with the art, what's priority, what can you get done, when can you do it. Sound designers, similar, list sounds and music in order of priority, when, and what can you do. So here are just some examples of gameplay loops. So here we just have, basic kill, find, continue. We have kill monsters, that's your action, then you get a reward. We find some gold, and then we continue on buying stuff and find more monsters, and just keep repeating. Pokemon has a bit more of a longer one. You have your explorer, you encounter a Pokemon, you might capture a Pokemon, you'll lose some stuff or gain some stuff, you collect more things, you eventually level up, you'll upgrade your stuff, and you continue the loop.
Has someone ever come up to you and told you about a great game idea that they're going to develop, and it's going to be awesome, and it's going to be all these cool features and stuff, and you've asked them, what will you be actually doing in the game? And they're sort of like, I don't know, we'll just, we'll be killing vampires and stuff. Lots of people have game ideas like this, but they're missing one of the key things that is the difference between something like a film and a game, and that's gameplay. We're about to cover how to go from having ideas and then get them into gameplay, into prototypes, into small games. Primary, secondary, and tertiary gameplay loops. The thing that you want to focus on the most when you're coming up with a game, when you're working on a prototype, when you have an idea and you're trying to get it into something, or if you're going into a game jam and you need to get something out really quickly, is you want to focus on the primary gameplay loop. The primary gameplay loop is the small loop of things that the player is going to be doing over and over and over. It's sometimes described as the thing that the player will be doing second to second. What is the small little thing that the player is going to do for the entire game constantly? In Call of Duty, this might be shooting and reloading. In a platformer, it might jump in and maneuvering around in the air. You want to take time to really nail down what the player is doing second to second and make it feel good. There's a somewhat famous story about the design of Mario 64. Nintendo didn't just say, hey, we've got a Mario game and start building levels. They spent the first couple of months of development in a blank room just working on Mario's movement so that his movement and actually getting Mario around the space felt as good as it possibly could. Naughty Dog had a similar thing they were working on with the Jack games, where they had two spheres, and their mantra for those games were, if we can get these two spheres to feel good to move around in a grey block-out level, once we dress it all up with art, it will feel great. Because the player is going to be doing the primary loop so much, really focus a lot of your time into getting that tune in right. Does the player know what they need to do? Is it fun to do? Is it juicy? Does it feel nice? Does it have lots of feedback? From there, you can think about the secondary gameplay loop. The secondary gameplay loop is the next level up from the primary gameplay loop. In the way that the primary gameplay loop is second to second, you can think about the secondary gameplay loop as what will the player be doing minute to minute. And it will usually be constructed of having to go through these little primary gameplay loops constantly. The secondary gameplay loop kind of gives you something to build towards. In a game like Mario, it might be a level. So you've got jumping on Goombas and taking out enemies as your primary loop, mostly just this jumping process of jumping on things and moving back and forth. And then you string that together in a series of those loops to get to a level. And you'll then do this primary loop over and over and over to complete a level, and then you'll do this secondary loop over and over to complete several levels in a row. You want to try and make your secondary loop explore all of the possibilities of your primary loop. Each different level in Mario will often introduce an obstacle for Mario to overcome by using his jumping and maneuvering skills, and that lets the designers really kind of play with that primary gameplay loop. It also gives the player some direction. It's important for the player to always have a goal, and so by having this secondary gameplay loop be tuned in enough so that they understand what they're doing, from minute to minute they're able to navigate their way around the game. The final one is the tertiary gameplay loop, and as you've probably already guessed, this can be thought of as the hour-to-hour gameplay. Now, not every single game is going to have 3 loops.
We'll stop here because we're not going to get to that. But the video is linked in the presentation as well if you want to watch the whole thing. All right. So here's some different ways that you can kind of go about planning your game. We just went over gameplay loops, but here are wireframes. This is useful if you're interested in doing AI or if you're going to be doing a 2D game. So basically, this is just where you're laying out, you have a nice big flat screen and you're just going to be laying out pencil, paper, that sort of thing, where things are going to go, writing out what's going to go where, just kind of drawing stuff out. And then we have the level design version of this, which is called gray boxing or gray blocking. So you can see a 2D platform level here where we have a denotation of where all the different platforms and directions and moving objects are. And then you have the 3D version that someone's built here in Unity, which is just a bunch of cubes that kind of define a space. Overall, if you want to complete a game in any time frame, make sure you define what your core mechanic is. Try to get it down to one statement, one sentence. If you can't say it in good, clean one sentence, it's probably too complicated. Try to define your pillars. What are the most important aspects of your game? The things that really shape its identity, and reference all decisions by these at every point in development. Make sure when you're about 3/4 of the way through, you make sure you check and say, hey, what are our pillars? Is everything that we've made so far kind of fitting with our pillars? Try to refine that. Create asset lists for sound, music, scripts if you want to have that be programming, and prioritize them because things will get cut eventually. There's just going to be stuff that you don't have time for. And then leave room for things taking longer than you thought. There's just going to be a lot of things that you never thought you would encounter, the unknown unknowns, just stuff you never expected. And then try to refrain from scope creep until the main gameplay loop is done and fun. That's it. Now we get on to the fun stuff.